So here we're going to talk about the imaginary unit and what we call a conjugate pair. When we talk about the imaginary unit, the thing we need to remember is that I itself, I is equal to the imaginary unit, and it's equal to the square root of -1, which means that anytime I do I squared, I get a -1 because you're undoing the square root. So all imaginary units must come in pairs. And this is the imaginary number. So we call the pair the conjugate. So if I take a plus bi and multiply by its conjugate, which is a minus bi, here's why we need the conjugate. If you multiply this, a times a squared, a times bi is a negative a bi. Then you have bi times a is a positive a bi. Then you have bi times bi is a negative b squared I squared. These are going to cancel, and that's what you want. You want imaginary units to go away because you can't deal with imaginary units. And then you have this I squared sitting out here. Well, I squared is equal to -1. So essentially what you're going to get here is a squared, -1 times negative b squared is a squared plus b squared. The shortcut for multiplying conjugates then is to square the a squared term and then square the b term. Square the a term, square the b term, and then add them. So look here, write the equation of polynomial having degree 3 and has zeros, 1/3 and 3 minus I. Well, they tell me that the degree n is equal to 3. And from fundamental theorem, that means I need at least 3. I need 3 solutions for this. They've only given me 2. They've given me 0x 1/3, and then the 0 is 3 minus I. Because this is an imaginary number, it has to come in a pair. And we're going to use this conjugate to write the pair. So my actual zeros are 1/3, 3 minus I, and then the conjugate for that is 3 plus I. The conjugate just changes the sign in the middle. It doesn't change the sign in the front. And so when I write this now, I get x minus 1/3. You're writing the linear factorization again. X minus 3 minus I. And notice how I wrote this as x minus because it's always x minus. And then you're writing x minus 3 plus I. So what we'll do is we'll clean up the imaginary parts and rewrite them as, we'll write this as, remember, this right here, you take the fraction right into an actual number like this by sliding the 3 to the front. So that's 3x minus 1 times. And then we're going to clean up this part first. And rewriting this, we get, see that that's x minus 3, distributing the negative, and then plus I here. And then, again, same thing, x minus 3 minus I, and distribute the negative here. So I'm going to multiply the imaginary parts first. When I do that, I get x times x, x squared. X times -3, -3x. X times I, negative xi. -3 times x, -3x. -3 times a -3, positive 9. -3 times I, positive 3i. I times x, positive xi. I times -3, negative 3i. Positive I times negative I is a negative I squared. This is nice because things are going to cancel. For instance, negative xi, positive xi, positive 3i, negative 3i. In particular, notice all of the i's cancel, and then you have this I squared term out here, negative I squared. Remember, that's just equal to a positive. That's equal to I squared itself is negative I, times the negative makes it a positive 1. So we clean things up now. In the front, you still have 3x minus 1. Then I have a x squared term right here. Negative 3x, that is a minus 6x. Then I have 9 plus 1, which is a positive 10. So from here I can distribute again. 3x cubed minus 18x. 18x squared, I'm sorry, plus 30x minus x squared plus 6x minus 60. Clean this up. Here's the final thing. Here's the final polynomial, 3x squared minus 19x squared here and here plus 36x, 30 and 6, minus 60. If you do this correctly, in the end, you should not have any i's left. The i's will always cancel out when you start to do your multiplication here.